Okay. And if you were following on our Slack channel, I do have a guy coming in. He said he'll be here right around noon or so um, to talk about some blockchain protocol stuff that's kind of newish, pretty interesting actually. He works with Aurora WDC, one of the companies that several of your classmates are interning with. William Bushy is interning with them. And actually, Williams worked with this guy, and he's going to be talking about something called POAPs, proof of attendance protocol, and then blockchain and stuff in general. And this is related to our classroom topics in that, starting to use blockchain for network communication, almost kind of thinking about it. It'll be an interesting decompression maybe on Tuesday to think about how this is almost like signals over the network, something like that, using blockchain. But I think it could be valuable information, and it's definitely bleeding edge, because this is something that's just becoming a thing and solves some other problems around some of the things you maybe heard of called like NFTs, non-fungible tokens. So Waleed's going to be talking today about kind of that stuff, and I'll interject as he maybe skips over something that's important that he assumes folks know about. But in any case, he'll be joining us shortly. So in the meantime, let's at least advance our thought process forward a little bit on our Bittorrent stuff. I won't give you homework over the weekend, mostly because I need to catch up on my grading anyways, and I want to give you a little bit more code to work off of. But in any case, so you bear with me a little bit. I'll give you a weekend off because of it. Otherwise, you were going to have an impossible assignment this weekend under my original plan. All right. So we did talk last time about this. Let me just kind of show you some pictures. This website actually does a pretty good job of explaining and also reinforcing what we spoke about last time with how BitTorrent works. So BitTorrent is a peer-to-peer type network. So the idea is it's something along these lines where you have a whole bunch of connected computers that are actually talking directly to each other rather than to some central server. Now we're going to say for the most part. We mentioned that last class that it's for the most part as well. So up to this point, we've written our chat server. Oh, I think I'm recording. Yeah. We've written our chat server in such a way that it's like this. This is a client server model where our clients all connect to the central server, and the central server broadcasts something to all the clients that are coming through. And that's fine. It's worked okay for us. But the challenge of this is it puts the burden of all of these, all the data movement on this central server. Now, for huge amounts of data or a lot of stuff, this could put a this could be a problem for the computation power of the central server, but at the very least, this is going to be a problem for the network capacity of this server. So this server is sitting there on its own internet connection, and even if it's a commercial internet connection that is synchronous, which is the same speed forwards and backwards, it's still not unlimited. And even if it's a place like Google or Microsoft, that presumably have ridiculous amounts of bandwidth, it's still not an infinite amount of bandwidth. And if 5 million people are all trying to download a single file off of a single server, it really doesn't matter how fast their internet is. They're not going to be able to, they're going to end up downloading very slowly because they're going to be sharing 1/5,000,000th of the bandwidth, something along those lines. All right, so we're less concerned about sharing the computing resources of this central computer and more about the data moving between these machines, because the more machines we have, the more the data. We started off with a chat server. More recently, we've been doing file sharing. Now we're moving actual amounts of data. I don't remember what the size of our image was, but 2-3 megabytes, something like that. I don't remember looking at it, but not a huge amount of data, but way more than the size of a string we were sending for chat messages before. Okay, very different situation. So the more we start doing that, the more this model becomes a problem. All right, so moving to this model makes more sense. What we talked about, so this is a peer-to-peer model rather than a client-server model. But these peers still need to have some way of learning about each other. So if we pretend like all of these clients are all interested in downloading the same big file, a la Bittorrent, they still needed some way of becoming aware of each other. And that is done through really still a model like this. This guy here in the middle is I mean, Bittorrent calls it a tracker. It's a server. It's a small piece of software that allows you to check in, ask a question, and what it gives you is a list of current participants on that network. More than likely, you even stay attached to that server because you want to know when somebody drops off or somebody gets added on, so you have one more or one less client to possibly share those bits between. So the way that these clients all know about each other, you know, the unique way, you know, these guys might be somewhere on the internet. They're not in the same room necessarily. So this guy has an IP address, this guy has an IP address, so on and so forth. So the way that all these guys know about each other is because they've asked the tracker to give them a list of all the IP addresses of the people currently communicating with the network on this particular torrent. So this is on a per torrent basis. So if you have a torrent for file A, a torrent for file B, a torrent for file C, this tracker is going to hand you a different list of IP addresses for the people that are participating in each of those torrents, whichever one you say you want to participate in. All right, so that central server is typically called a tracker. All right, so go ahead.
I have a question that is almost certainly dumb. What exactly is an IP address? Is that like per computer?
Didn't we talked about that in class, didn't we?
Yeah, probably.
Just killing me. You were just killing me.
We definitely did.
All right, here, I'll remind you. When we first made our transition from talking about process IDs of multiple applications running on the same computer, I then asked, well, what if we have processes running on different computers? How do we uniquely identify processes on different computers? Well, we need to know so the IP address is the unique address of a computer on the internet, let's say. It can get a little bit more complicated than that when we talk about routable versus non-routable IP addresses and edge routers and things like that. But I think I even showed, if I come up here, so I'm on my Wi-Fi here at my house. So my IP address is 192.168.1.126. This is a non-routable IP address. So if you were on the internet, if I ran my chat server right now, you would not be able to reach my computer because my computer is not actually, it's only unique on my little local area network right here. I think we had a similar thing at the school. I don't remember. Actually, I think it was a routable IP address at the school. I think it was 172 something, which meant that its protection was the router firewall. But in general, we can say that an IP address is a unique way of identifying a physical computer on a network. All right, and typically when we're talking about client server or networks like we're talking about right now, it is important that it's unique across the internet, let's say. If we don't have it unique across the internet, we then instead would require this central thing. So like in our example, for our current file sharing has this computer connect to the server and say, okay, I'm going to send a file. this computer connects to this computer and says, I'm going to receive a file. The IP addresses of these two computers really are not important, as long as they can both reach this guy right here, because this guy is going to connect these two sockets up so they can send and receive data, because they've opened the door to this guy. This is how certain software applications you've probably used before, like what's the name of it? Well, VNC viewer, VNC server, those two work together that way. What's the name of the team? I don't have it on here. Team viewer. Is it team viewer? Any of those applications that allow you to remote into a computer and control it remotely. Those guys, they work by having the person's remote computer open a connection to a unique IP address that's open on the internet. So anybody else who goes to try to connect to it goes through that server to get to that connection. So that way you can bypass any firewall. Firewalls are usually one way. They allow you, yeah, of course I actually have two Wi-Fi networks just for VR. This is only my 2.4 gigahertz one. I have a 6 gigahertz one now for PC VR across wireless. Do I have a dedicated? Yes, of course I do. It's got its own router and everything. It's not even just a different SSID. All right. So anyways, an IP address allows a computer to be uniquely identified on a network. And then how do we get to a particular application running on that computer? We do that through the port number. So those two working together allow a computer application on one machine to reach a computer application on a different machine. Yeah, Wi-Fi 6 is the new stuff, James. Lower latency, yada, yada, yada. So right now, the higher the gigahertz for a Wi-Fi network, typically the closer you have to be to it to get maximum speed and minimum latency, but the more bandwidth that it gives you. So I do, let's see, I do my VR in my living room mostly, which is close to directly on top of my VR room in my basement. So actually the distance between where I do wireless VR and that router is probably less than 10 feet for sure through a wooden floor. So not a whole lot of interference. And I run all the video. I use a piece of software that allows me to do DisplayPort uncompressed over Wi-Fi. So it doesn't compress the video. So it's as if I have it plugged into the machine. And I would say I pretty much think it does its job. Yeah, the 5.8 gigahertz ones they're still probably the common one. There's just a new Wi-Fi 6 protocol that you have to have a special card that's capable of talking it and a special router that's capable of sending it. It just adds, like, I think it's 2 more channels of communication. It's, you know, a marginal speed upgrade, but, you know, technically the latest, greatest, yada, yada, yada. And frankly, if you bought a new computer today, it probably has a card in it capable of Wi-Fi 6. Okay, so does that answer your question, Jason? What an IP address is?
Yes, thank you.
All right. But it is an interesting question, because when we do talk about the idea of a firewall, you know, we kind of throw these terms around quite often. It's like, oh, are you behind a firewall? Well, what does that even mean? So like at the university, if you guys live on campus, or right now you're on your computers, maybe you're on campus, whatever. Let's assume you're on campus right now. you are behind a firewall because the university has an edge router. So they have a piece of equipment that sits between the university's internet connection and the university's internal network collection of networks, because it's going to be a collection of local area networks that make up all of Concordia's internal networks. But what sits between all those networks and the outside world through that internet connection is that router, that piece of hardware equipment that all data comes in and all data flows out through. And typically when we say that you're behind a firewall, what we're saying is that any external connections have to go through that firewall in order to get to any computer on the inside of the network. And typically routers, typically firewalls, will block all of those incoming ports. So the router itself will have an IP address. So that's actually, we can say that's Concordia's IP address, is the IP address of the router. Think about it like our bouncer at the door. And he has the same 1,024, actually more than that, 65,536, let's say, unique ports. And by default, every one of those ports is closed. So effectively, that bouncer just turns away all visitors. Now, the network administrator, so in our case here, like Mark Newhouse, he would go in and he can say, well, I want people to be able to reach Concordia's web server. So when you type in www.cuw.edu, it goes to Concordia's webpage. Okay, well, if you're going to do that, that means that web browsers by default go to port 80 at an IP address. So he's going to have to instruct that router to unlock the door for port 80 so that incoming connections to port 80 get through. Now, typically a firewall is a one-way street. So that bouncer out there, he has all the doors locked, except in this case, port 80, let's say, also probably email ports. But in our example here, let's just say he has all the doors locked. But one of our internal computers could open that door. So if we're at a computer here and Concordia sits here in the middle, and we open up a communication channel to some server in France, let's say, now all of a sudden a door in our router is open. We opened it from the inside. And now people can get into our network by the output stream of this open socket, because we've opened the door and we've given them a communication channel to the inside. Now, that data is still going to have to go through this computer here. So this computer here gets to decide what to do with any incoming requests. But that's actually how some of those things like TeamViewer and the VNC allow you to control computers that are either on a local area network. So for instance, do I have VNC on here? I don't. So control computers that are on a local area network with a non-routable IP address, like my machine in the basement, my VR machine, it has a non-routable IP address similar to my computer right here. Yet if I'm on campus, I can get to that computer. Why? Because if we assume this is my basement computer, he's opened up a connection to VNC's cloud and held that door open. So he said, okay, I've checked in and I'm available to be remotely controlled. Then from campus, I can open up a connection to VNC's cloud, who then connects me to this communication port. So it's not reliant on being able to directly connect to this machine. Instead, it's just connecting the two wires together of this open connection. So that's kind of like the I don't know about the trick, but the cadence of network communication is sometimes you have to have an internal thing open the door because externally the doors are locked. Something like that. But in our current example of our file sharing, we have two machines with two different IP addresses, but the IP address of the two clients don't really matter. They just both need to be able to reach the IP address of the server. So these guys can be anywhere in the world as long as they can reach this guy. And they both connect and they say, okay, I'm the receiver, I'm the sender, and then this guy passes the bits. This guy sends the bits. Then he sends them on to this guy, and that's how everything is moved. But that puts a burden on the server's network bandwidth. It only has so much bandwidth to hand out. So with BitTorrent, the idea is that we have all these connected clients, and rather than having them talk to each other directly, we want rather than have talk to each other through a server like we did up here, we want them to talk to each other directly like this. Okay, so creating these communication channels. Now, where it does get a little interesting here is if I'm sitting here at home and I have a fake IP address, a non-routable IP address in my house, and I'm going to be using BitTorrent for something, and I'm seeding a file, which means I have at least a part of a file that maybe this guy wants. How does this guy directly reach my computer if I have a fake IP address? I mentioned this idea of a tracker. So a tracker does create this situation for us. He creates that situation for us. But at the very least, what does this tracker have to do? He has to hand out the IP addresses. So when this guy connects, he's going to let this guy know about all of these other 5 guys, so that he has a list of all the people sharing the file that he's currently interested in. This tracker, that's what he would do. But what if some of these IP addresses don't actually, they're not actually directly connect, you can't connect to them directly. So in my example here, my computer's 192.168.1.126. This guy right here, that's my IP address. I can tell you that's a non-routable IP address. You can tell right off the bat when you see the 192.168. That's just one of the known non-routable IP addresses that are used only for local area networks. So if some of you are at home right now, it's entirely possible that you have this identical IP address. Not necessarily probable, but possible, because your computer is uniquely identifiable on your home network. My computer is uniquely identifiable on my home network, yet the IP address of my actual router, my Wi-Fi router, it probably has a actual unique IP address that would be different than your actual unique IP address. It might even go one more layer. It might be that my internet service provider, Spectrum, may have actually handed out a non-routable IP address to my router, because my router might be a computer on Spectrum's local area network, something like that. So it could be multiple layers. But if we assume that in terms of BitTorrent, a lot of times if you're using BitTorrent, there's a very, very, very good chance that at least a lot of the folks are not on the same network. So we need to have some way of this guy being able to talk to this guy directly when this guy can't open up a socket connection to this guy directly, because this guy's IP address is non-routable. If this guy tries to connect to 192.168.1.126, that is not an IP address that's unique on the internet. Therefore, he can't get to it. So we need to say, well, how do we actually have that communication occur? So that's the problem we're going to look at either near the end of class today, depending on how long Waleed goes for, or on Tuesday, is how do we use this tracker to not only give us the information of who's currently participating in a particular torrent, who's willing to share bits, but also how do we have this computer talk to this computer, for example, directly, if they both have non-routable IP addresses, which is extremely common. Any of you who have a Wi-Fi router at home or in your apartment, your computer has a non-routable IP address, which means, and you've probably used BitTorrent before and seen that it works. So somehow these external computers are able to send and receive bits from your computer, even though your computer is not uniquely identifiable on the network. So we need to talk about how do we accomplish that. Okay, so I think I saw Waleed is on. I turned on screen sharing for you, Waleed, if you would like to do that to kind of talk about, let's assume that a good portion of your audience doesn't really know much about blockchain or the different problems, real life problems that can be solved on blockchain other than, hey, I have Bitcoin. So talk about maybe blockchain in general, talk about NFTs in general, and then I know you're working a lot with this proof of attendance protocol with POAPs. So talk about kind of what problems that's solving related to NFTs and maybe how it works. That sound like and then anything else you want to talk about is fine as well. That sound like a reasonable plan?
Yeah, sounds good. Sounds good. Hi everyone. I know some people here know me, specifically William, who's I'm gonna invoke his name later on when I'm talking. My name is Waleed. I graduated from computer science last year. I'm working with a company called Aurora. We're doing a variety of things. One of those things is that we're working with blockchain technology to utilize this technology towards community stuff. Now, a question to answer first is, what is a blockchain? Probably most of you here know or have an idea or have heard of, because of the recent buzzwords, have heard of blockchain, what it does, slight idea maybe. And basically, just to put it into perspective here, but just the simple answer is, consider blockchain is a big database of transactions, and people call it decentralized or distributed, however you want to call it, just because it's not related to one entity per se. I want to pick my terms correctly here. It's distributed upon nodes on the internet. So let's assume, back to the slide that Dr. Littman was previewing a minute ago, where you had all those computers talking to each other. Consider those as nodes on a network, being the blockchain network, where each node have a portion of that big database that I was talking about, a copy of that big database that I was talking about, filled with transactions, and they're passing this information around between them. And that's why they're distributed and decentralized in that sense. At the same time, that's how they share that information on the network. So, and by the way, feel free to interrupt me, ask questions, or put in the chat if you want to. Again, I know some of you have worked with me, know me, but I'm here today because we are trying to work with blockchain NFTs and implement that solution within Concordia. And I mentioned NFTs, Dr. Lettman mentioned NFTs, and I'm going to talk about those in just a second. So at the very basic level, again, as I said, a blockchain is the database of a bunch of transactions, and those each transaction is encrypted. And this encryption is called a token, and that token is what you see as Bitcoin, Ethereum, whatever blockchain token you can think of. This token is changeable. If we think of Bitcoin, for example, versus the dollar, the US dollar, those are all changeable. I can give you $1 and you can give me an exact one paper dollar back. That's the same thing. It's not going to be different. I can give you one Bitcoin, you can give me one Bitcoin back. It's the same thing. Now with NFTs, they have a unique structure to them, where if I give you one NFT and you give me one back, both of those are unique. So they're not, they have their own distinctive identities. So they're not like $1 versus $1. They're non-fungible in its term, because they're called non-fungible tokens, sorry, but they have their own unique ID. What do I mean by that? What I mean by that is, when we think about JSON databases, and I don't know to what extent you guys have experience with, I'm betting all of you have experience with JSON at this point, but when you think about JSON databases and you think about key value pair, items or things in this database, and you have first name Waleed, last name X, and then you have transaction ID 123, and you have to account, which means Waleed transacted one or something to Dr. Littman's account. But then all this data is encrypted with a token, as I said initially, and I'm adding an image to that, or a video to that, or even a sound audio to that. Now, what's the difference here? What did I make here? The audio, if I exchange that audio, if I exchange my voice right now with Dr. Littman's voice, I'm pretty sure you're going to know the difference of who's speaking. So that's how unique it is of exchanging, items from, instead of exchanging a Bitcoin, for example, or one USD, which is different. If I give you one USD, give me one back, it's the same thing. But if I give you an image of myself and you give me an image of yourself, that's entirely different. That's a different thing, and we can then value those two different things differently. We can say that my picture is worth $10 and your picture is worth 100, because there's two different things, right? So this is a simple and basic idea of what NFTs are. And Dr. Littman, I don't know to what extent you wanted me to go out with there, but I just wanted to cover a more of a general ground before I start talking about POAPs here.
I would say an important piece would be, a connection that typically is a problem when you're learning about a new technology is don't just talk about what it is. Give an example, like a easy example of how it might be used. Because I think maybe the exact details of how NFTs work, while those can be important at a later point, I think kind of just hitting the highlights of how they work, but really some examples of how they should be used, I think kind of will close the gap for your audience so that they kind of know, well, why do these exist and why do I care?
Right, and that's exactly why we are going to talk about proof of attendance protocols and POAPs, and with the idea that I just gave about NFTs, people started thinking, well, how can we utilize that technology, for something useful? And one of the utilities, one of the utilization factors of NFTs is POAP, proof of attendance protocol. This is a solution to a problem per se, if you could say that, where I want to provide a way to prove that a certain group of people attended an event, for example. The POAP team, the people who designed and created the NFTs that are called POAPs, have designed this as they say it to quote unquote record life events, where if you have a wedding or you have a birthday or stuff like that, you can create an NFT, which is basically an image that's stored, and I'm not gonna go into detail here, but basically an image stored as a database record of you having a birthday this year at somewhere special. And this is how they code their product, that you can use that for any event that's special to you. But actually what's been happening is people have been adopting that mindset. And for example, you know, creating events where people who participate in that event have the right to claim that NFT, to take an NFT, and then they can use that NFT later to go to this exclusive party, for example, just to put it simply. So let's say that we do an event today at 6 p.m. and whoever's going to attend that event will have the right to claim a POAP, to have an NFT claimed. And I'm going to talk in a second about how you can possibly claim that NFT, or what does it mean to claim an NFT. But once you claim that, if you come to our party at 6 p.m. tonight, or come to our class, let's assume 6 p.m. tonight, you'll be able to claim one NFT or versus one POAP, or actually one POAP, one NFT. But that would give you exclusive access to, let's say, a summer event that we're making in 3 to 4 months, because you have that POAP. So people took that into perspective of, well, yeah, you put that to work. We can take that and add some exclusivity to it for people to attend other events, or as we're doing with Aurora, for example. And William, I'm going to invoke your name quickly here, where people who claim POAPs can, for example, well, not for example, they will have the right to have a what's it called, like a slot in a raffle, where we create raffles for people to win stuff. But in order for you to participate, rather, in that raffle, in that competition, to win that thing you're going to win, you have to have claimed at least one POAP, one NFT. So there's a business case here behind it, where, oh, well, if I want to, so for example, our upcoming raffles are going to include an award of a Quest 2, an Oculus Quest 2 VR. So whoever have claimed NFTs with us before will be able to participate in that raffle. And whoever participates in that raffle will have a high chance of getting an Oculus Quest 2. So you're playing the game now of, well, hey, oh yeah, I want an Oculus Quest 2, so I better follow that company or what they're doing to see how can I claim a POAP. And once I claim that NFT, well, now I have a chance of winning that Oculus Quest 2, or even have a chance of, and this is far beyond this discussion, and we're not doing this with Aurora, at least at this point, have a chance in voting within a company, for example. And I'm not going to dive deep into that. I'm just giving you generic sample ideas of what people are thinking of, tools you can do with having those NFTs or POAPs, if that makes sense to you all. So this is one way to think of, well, why would I even want a POAP? Why would I want to claim that NFT? Well, a lot of different reasons. You can claim that now. And for our case, we are testing this system with Concordia. We're going to build some stuff with it later on. So this class, for example, will be each one in this class. I would encourage you that I will show you later, but scan and attempt to claim that POAP or NFT, have it with you, because guess what? Let's not say next semester, but in a month or so, if we decide to do something only for people who have claimed that POAP with us, you'll be one of those people. No one else. You'll be the one, because you have claimed that POAP. And so the final thing I want to say about this part is, because I keep saying claiming and taking the POAPs and all that stuff, I talked about blockchain and NFTs. I'm assuming some of you have heard about crypto wallets, Metamask to be specific, because it's the famous one out there. I'm assuming at least some of you have heard about public addresses. And what those are is, as I discussed in the very beginning, in a very simple way, again, just to stress on that part. How a structure of blockchain is, and it's basically a big database with encryption keys to each transaction in it. And a public wallet or a crypto wallet is a way for you to store that transaction, your transaction. So if somebody sends you a transaction on the blockchain, you'll be able to accept it, receive it, and store it in that wallet. Now, how that wallet specifically works, I think, is beyond our discussion at the moment. I don't know, but I would highly recommend you guys to look into MetaMask, to be specific. Their website is highly easy, easy to understand and go through. For now, you would just think of that crypto wallet is your repository to anything crypto you're going to be working with now or in the future. And MetaMask is going to be your first key to that repository. There are other ways and other wallets out there, and by other ways I mean excuse me, I mean that there are hardware ledgers, hardware wallets, like physical wallets that you can have to store those, but this is beyond our conversation. So I would highly suggest you guys look into MetaMask. This will give you an idea. Dr. Littman, before I share my screen and allow people to scan the QR code to claim their POAP, I would like to invoke William's name because he's been working with me a lot on this, on a similar project related to POAP. He also, he does more work with POAPs than I do. So I want to give him a minute or two to talk about POAPs.
Did you just say you want to invoke his name?
Yeah.
That's going to go right to William's head. He's already on a power trip.
Okay. Okay. So yeah, until I share my screen, I'd like for William to talk about his work with POAP, explain a bit, talk about a bit about POAP until I share my screen, and he's gonna probably explain more about that screen I'm gonna share than me.
Yeah, and then make sure to kind of cover the the why. We kind of picked this group as like a test group, but they're not preheated at all. So kind of give them the background there too.
Right. So I can talk about this now quickly. So we have created this NFT that's called CSC450 Systems Programming Class. That's specifically for this class. Has a spring 2022 on it, which again, it's specifically for this class. And we want you to be our test group. So everybody on this call, everybody on this in this class, whoever claims the POAP, and again, if we decide a month from now, when we decide a month from now to do something with those POAPs, anybody who've claimed POAPs during this class, you'll have exclusive access to that thing we decide to do a month or a couple of weeks from now. But also we have plans to expand on that. And I don't think if you want me to talk about that now or not, but we have plans to expand on that by giving validity to you as a student by claiming that POAP if you passed a programming class, for example, or a certain class, a certain exam, for example, which would then, in the eyes of an employer, give you a credential that, well, you have a record of passing that class, or sort of a certificate, but a crypto certificate, blockchain certificate on the blockchain. That's not going to change, not going to, I don't know, have anything changed to it. But yeah, we have plans in the future, in the very near future, with those NFTs, and you're our very first participants. So whatever we decide to do with that afterwards, you'll have exclusive access to that. So with that, I'm gonna, William, if you want to talk about POAPs until I share my screen from OBS, and it takes a couple of minutes to do that, so take your time.
Yeah, so Wally definitely covered most of everything, and I just want to preface, really the only thing that I have to add is this technology is still very early. Many of you are familiar with the news grabbing headlines about how much a picture sold for, and you may be thinking, well, it's just a picture, what's so special about it, stuff like that. And I think the community that is involved in NFTs specifically is trying to discern what actual use cases there are for this technology, because right now it's, like I said, in its infancy, and there's a lot of experimenting with it. And so POAP is definitely a way of actually utilizing the technology for what it's meant for. So POAP can be used for event tickets, to allow you to get into an event. It can prove that you were at an event. So it's finding use cases like that that will push the technology in a better direction, I would say.
And I would like to answer Emily's question with where the tech for this is right now, how easy it is for non-tech people. So Emily, what do you mean by that, if I may ask you?
Like, for example, if my mom wanted to use this and like claim an NFT or a POAP, how easy would it be for her to use it and understand it? Kind of like going away, kind of like where VR is right now, where it's trying to go away from just like the gaming industry, where like NFTs are trying to go away from just like the, oh, look at this cool picture online industry. How easy is it for like a common person to use it?
So it depends on the business model, right? But let me take the POAP example, just to try to answer your question. And it's kind of in the middle, to be honest. It's not easy and it's not hard. It's kind of in the middle here. And for example, I've seen 5 people are claiming, 6 people are claiming. That's good to see. But for example, POAPs allow you to claim using a QR code, which is pretty simple to do, and you can claim with your email address. So almost everybody has an email address, right? So so you can claim that NFT with your email, so you don't have to worry initially about what a public address is, what a crypto wallet is. But all you know so far, you don't even have to care about what an NFT is. And by the way, this goes to part of what we do at Aurora, by the way. Most of our audience, almost all of our audience, and William can add to that, do not know what an NFT is. And up to this point, I would say maybe 20% of them don't care what an NFT is, because what they're getting from our side, and this goes back to the business model, is a ticket to something. At this point in time, we're doing a promise that, not with you guys at the company, that hey, claim that NFT and you'll have access to a upcoming raffle to win an Oculus Quest 2. Well, if you change your terminology a bit and say, if you claim that image or ticket, you'll have access to that raffle. Now you take away all the things that people have to worry about, the public wallet, the NFT terminology, all that stuff. And then if you really want to teach them what a crypto wallet is, what is a ledger, why would they need it? Excuse me, as I mentioned earlier, and this is, why is it a repository for your crypto stuff? It's like an app. It's actually an app. And if they get used to that app, they don't have to worry about what an NFT is. So again, I know I spoke long about this, but to answer your question shortly, sorry, it goes back to your business model and how you address your audience. In our case, again, not this case, I mean, in the company, most of our audience are not tech savvy, and this goes directly to your question. But in our case, our business model doesn't speak to the technology of the blockchain. We use it, but we don't talk with our audience about it much at this point. So we play the game of, this is a ticket to you winning an Oculus Quest 2. Does that help a bit with your question, Emily?
Yeah, that makes sense. Thank you.
So, and I did talk about something here that I want to stress on with this class, especially with the 11 students who have claimed those POAPs or NFTs. And I'm guessing most of you, if not all, and I might be wrong, have claimed those POAPs using their email address, because most of you do not have a public crypto wallet or a public address to add in there. And that's fine. But again, I would encourage you, to get a public address, know about Metamask, install it, because once you do that, you'll be able to go back to your email, go back to your NFT or POAP you just claimed, and see it in your app, in your wallet, and have it there for as long as you want. And by the way, you can have it as claimed by your email address for as long as you want, but we're encouraging you to know what a public wallet is, what a crypto wallet is, what a MetaMask is. And William, thank you. He just shared the website for it. And I'm gonna actually just ask you this question because I know you're familiar with this. I don't think their POAPs will expire when they claim via email, but we're not going to be able to, well, we'll be able to, but we would encourage you to create a crypto wallet to store those NFTs in, instead of going to the website to, see your collection. You'll be able to have a repository for your crypto collection. By the way, just a quick incentive here, just a quick news for you here that was shared to William and I last week or 10 days ago. There is a pretty infamous group in the crypto world called Super Rare, if you guys have heard of it. They've been in the business for a year now, I think. And they've really grown exponentially throughout this year. And they've been using POAPs at the beginning of their initial phases for their events, so that they can have proof of attendance for people who attended their very first event, or a couple of events in the beginning. And just to give you a perspective, those people now have the capability of transforming their NFTs into Ethereum. Ethereum is a cryptocurrency that we just talked about a minute ago, which, when I said you can exchange one for one, but they can exchange each ticket they received for each event they attended. Each one ticket, they can exchange it for 10 Ethereum. 10 Ethereum now is about $34,000, I think, $35,000. So if I attended 10 events with them when they started, now I can claim those for $350,000. Now you're talking value in addition to business. So, this is to give you another broad idea here. So yeah, that was basically it. I don't know, Dr. Lippman, if you want to add to that or not. I'm glad we have people scanning. I asked for extra codes just in case. I didn't know how many students attended your class, or the CS450 class to be specific. But we're going to have more of that coming soon for other classes. The last thing I want to say here again is stress on you guys taking the time, 10 to 15 minutes, to go to the Metamask website, exploring what that is, and maybe creating your first crypto wallet to have that repository.
Yeah, so I just put up a picture on our Slack channel of like what the I went ahead and minted one and took a picture of what it looks like when it's done. I can go ahead and take a screenshot of the QR code. And I can put that up there as well for people who want to go and do this later on. But one thing that I ran into, I don't know if other people are running into it as well, and I know it's something you mentioned, but I had to scan 2 separate times. So they said, oh, there might be a lot of people doing this right now. Kind of an interesting thing is if this is happening while you're, for the attendance protocol thing, using it to take attendance, presumably a whole lot of people would be scanning all at the same time and having it fail. Is there a fix for that, or is that not the correct use case? What's the deal with that? It did work my second time, but the first time it said maybe there's too many people scanning at once.
Yeah, so it's with this specific solution that we're working, and obviously we're gonna expand on that, and we're gonna do our own. But this is a very basic setup that we get from POAP, and with this specific solution, it doesn't allow for multiple scans at the same time. So you have to, one person has to scan, and then the other person has to scan afterwards. But we will certainly work on solutions where people can, or at least attempt to work on solutions where people can scan at the same time and claim without this problem occurring. But yeah, with this current setup,
that's kind of related to things we've been talking about in class with like these race conditions, although this is happening like in human level slow-mo, where I just wonder, did 2 people scan at roughly the same amount of time, like within 1 second of each other, and that's what made it fail for me? Or was it that, another token was currently being minted and a new one could not be done until that one was finished? Like, what's the real time gap between what will work versus what will fail? Do you know that?
Yeah, so I know that to some extent, but the funny thing is, I think ironically, you just said it, that you were scanning at the very same second as someone else was scanning the code, which is by the way, it's not rare in this setup because of how it goes. And William, thank you for posting that in chat. The QR code waits for somebody to, put the camera on, click the link for it to change to another link. So, in that millisecond where you were scanning the QR code and clicking the link, somebody else was scanning the same code and clicking the same link at the same second and that's why it failed. If that makes sense.
Yeah, so presumably if you are taking attendance and people are coming in one person at a time and they scan, presumably there'd be like a 2 or 3 second time gap between people scanning. And so you're saying that would be okay. It would not fail then if there was like a couple of second gap. This was because you had put out a public QR code that all of us had the opportunity to potentially scan at the same time, as opposed to having people like scan something at the door as they're walking in, where only one person is coming through the door at an exact moment.
Oh yeah, absolutely. And there are other custom-made solutions that we can explore, and we can do our own also, but this is just the basic setup. And yes, to answer your question, yes, exactly. If it's set up that way, where at the door, people are scanning one by one, it definitely will give a couple of seconds to, to allow for that transaction between scans.
And is there the opportunity to, or the ability to like limit the number of tokens that can be minted by a single person, like on a single day? I guess what I'm kind of thinking about is using this to take like classroom attendance. Like, can we make it so that somebody can only scan once per day, but they can scan, every single class period. So at the end of the semester, they have, 50 tokens, and that is equivalent to, the number of times they attended class physically or something like that. Is that something that makes sense for this protocol, or is that not really an acceptable use case?
No. Actually, that's how we use it actually now at Aurora, and that's totally acceptable. Where, for example, we have those podcasts or shows that people attend and claim those NFTs or POAPs for attending those podcasts. But then at the end of the, we don't have semesters, but let's say in a 3-month span period, we can look back and say, oh, Waleed has collected 20 of those NFTs for attending 20 shows. And that goes the same for any event you want to do. So for class, for an exam, not an exam, but for a class, for an event, whatever. By the end of the semester, for example, I can do something like this next week and the week following that, or next class and the class following that. And by the end of the semester, we'll have Emily, for example, having 15 NFTs for attending 15 classes from now till the end of the semester, if that makes sense. But yes, totally, that's how the protocol works. And that NFT you just claimed is generic in its design, just for the purpose of this class. But obviously, what you'd want to do is add a specific date to each design of the NFT, so that people know when they look at their collection back, or even when we look at the collection back, we know that. Sorry about that. We know that Waleed has claimed 5 POAPs. The first one was on what today is. The first one was on the 21st of April. The second one was on the 28th of April, and so on and so forth till the 5th one. So yeah, definitely that's how it works.
Okay, are you able to tell on your end? Let's see, it says, this is just it's probably updating in real time. So 15 of 25 codes have been claimed, so 10 people have them at this point. Is that accurate?
No, the 15 people have it at this point, I think. So yeah,
15 of 25 codes claimed. Okay, I get it.
Yeah.
So actually, that's almost that's pretty close to the whole class. In fact, that is the whole class.
Yeah, that's pretty good actually. And so I can, if most of them claimed using their emails, I don't think I might be able to, but I have a way of checking, of course, who claimed the POAPs, or at least I have a way of going back to the event I created and seeing the gallery and seeing the people who claimed their POAPs on my end. But
so sure, if you want, just so they can see what's behind the scenes later on, maybe go in and take some screenshots of that and put them into the 450 Slack channel. Just so they can maybe see what the back end of the POAP management thing looks like. Maybe that allows them to kind of start thinking about what other things they can use this for.
Yeah, sure. And William just shared the because he has the event ID. He just shared that 4 people have claimed using their public address, for example. So out of those 15, 4 people already, I'm guessing you're one of them, and William is one of them. for people who have crypto wallets and have claimed the NFT using their crypto wallet or using their public address at least. And then that would mean 11 have claimed using their email address. So yeah, so we want people to explore more their the MetaMask again and reclaim. You'll find in your email, but reclaim those NFTs in your MetaMask for better trackability of it. Yeah.
Yeah, I already have a wallet, and
Yeah.
it is $500 lower now because I was recently scammed by a friend.
But yeah, that was 6 months ago. I'm guessing it's 500,000 over now. But yeah, I know. That said, though, it's a sad fact in the current technology, and it goes back to Emily's question because of the fact that most people are ignorant of the technology, and by ignorant I just mean that they don't know the technology much. Games are played now where recently, even more recently, even markets have been developed that claim to sell NFTs and they're not selling NFTs. So you'd want to, as a computer science student, you'd want to take some time throughout the week to get to know that stuff, just for your background knowledge. That's it. So yeah, I think with that I conclude. I think I would encourage again, lastly, those 11 who have claimed using their emails to set up a MetaMask and reclaim their NFTs to have them visible and have them in their wallet. But otherwise, if you guys have questions for me, I'm happy to answer them.
Crickets.
Yeah.
Okay. Well, so we'll look for that picture or whatever up on the 450 thing so people can see what's behind the scenes. Otherwise, we'll no homework over the weekend, and we'll one thing to ponder is what we talked about earlier with the Bittorrent technology is how do two clients communicate who are sitting behind a firewall end up communicating with each other, because that is a common use case for Bittorrent. When you have a computer behind a firewall and I have a computer behind a firewall, and the two of us need to be able to talk to each other, yet we don't have a unique way of communicating with each other because we don't have a internet unique IP address. So think about how that's solvable, because that's what we'll talk about on Tuesday. All right, questions, comments, concerns, bribes. All right, I will see everybody on Tuesday.
All right, thanks everybody. All right, see you guys.